Exponential functions. Exponential functions have x as the power of a constant. So for example, 3 to the power of x. They are defined by the rule y equals a to the power of x and y equals a to the power of negative x, where the constant a is always greater than 0. Their graphs are shown below. So we have a graph here at the top, okay, the first one on the left. That is a to the power of x, where a is greater than 1. So it might be 3 to the power of x or 5 to the power of x. That's what they look like. And then on the right hand side at the top, that one is y equals a to the power of negative x. So it might be 1 to the power of negative x or 3 to the power of negative x. And as you can see, it flips around and goes the other way. When a is greater than 0 but less than 1, the shape of the curve is reversed horizontally. Okay, and when a is 1, the graph is flat line, y equals 1. So key features of exponential graphs. The graph lies wholly above the x-axis because a to the power of x is always positive, regardless of the value of x. It is impossible for the y values to be 0 or negative. So what that means is that when we have an exponential graph, if I have my x and y axes, when you have an exponential graph, your graph line will always be above the x-axis. It will never go below the x-axis. The graph always passes through the point 0, 1, because when x is 0, then y equals a to the power of 0, and we know that anything to the power of 0 is always 1. So it will always go through the point 0, 1, regardless of the value of a. The x-axis is an asymptote. That is, it is a line that the curve approaches by getting closer and closer, but it will never touch it. Okay? An exponential graph will never touch the x-axis. The graph y equals a to the negative x is the reflection of the graph y equals a to the x about the y-axis. Increasing the value of a, such as changing y equals 2 to the x to y equals 3 to the x, affects the steepness of the graph. The y values increase at a greater rate when the x values increase. The exponential function y equals a to the x when a is greater than 1 is often referred to as a growth function because as x values increase, the y values increase. The exponential function y equals a to the negative x when a is greater than 1 is often referred to as a decay function because as x values increase, the y values decrease. This slide will be very useful when you go to do your questions as it gives you the key features of exponential graphs. So when graphing an exponential function, step 1 is to construct a table of values. Step 2 is to draw a number plane. Step 3 is to plot the points. And step 4 is to join the points to make a curve. So graphing an exponential function, we have the graph y equals 3 to the power of x. Here are our table of values. So on your calculator, you would write, for the first one, you would type in 3 to the power of negative 3, and that would equal 1 over 27. Remember to always keep our negative values in brackets. Then this is what the graph would look like for y equals 3 to the x. So as you can see, it comes along the x-axis, okay? It doesn't touch the x-axis. This picture looks like it does, but it doesn't, but it gets super close. And then it will go through the point 0, 1, and then it goes up, okay? If we have a look at the reverse graph, y equals 3 to the minus x, You can see it's exactly the same graph, it's just been flipped over the y-axis. Once again, going through the point 0, 1.